Hi, in this is section 9.8. This is page 606. We're finishing the last section of chapter 9 today. This is called Factoring Polynomials Completely. I'm going to write page 606 here. And you might want to start off on page 606. And the first thing we want to do, actually, I'm on page 606 and 607 right now. What we want to start off with first is the following. Let's talk about what it means to factor polynomials completely, all right? To factor polynomials completely, we need to follow the following steps, and every one of these steps you've already learned in this chapter except for the last one, and I will cover the last step today. So when you look at any polynomial that you want to factor, the first step would be to factor out the greatest monomial factor first. And if you look on page 607 at the very bottom, there's a red box, and they show an example of that. You might want to pause the video and look at that example. Always try to find the greatest common monomial factor first. Then from there, the next thing would be to look for a special situation if there is one. Remember, we just finished a lesson in section 9.7, two special cases that can come up. You could have a difference of squares. That would be one of the special cases, or a perfect square trinomial would be the second special case. I ought to write that in there, perfect square trinomial. Here's the first special case, second perfect square trinomial, okay? And remember, if you recognize those, trinomial, if you recognize those, that will save you some time as far as having to factor the most common way. Now remember, the most common way of factoring is what we learned in section 9.5 and 9.6. If the lead coefficient's 1, then we have to figure out what times what is C and then adds up to B in the middle. And if the lead coefficient's not 1, then either you got to do the hokey method of taking A times C and working it out, or doing it old school the way that I showed you in my 9.6 video. So you have to go through that process to factor completely. Now there is one situation we haven't talked about, and that is if we need to factor a polynomial with 4 terms, and we can do that by grouping. So if you have a 4-term polynomial, you can group it, and this is new in what we will learn today, all right? Let's just quickly review some of the things that we talked about in the chapter, just because it has been a long chapter. The first rule of factoring, remember, is grouping, and I'm sorry, I misspoke. Finding the greatest common monomial factor is what I meant to say is the first type of factoring we learned. And just a quick review of that would be something of this nature, where I have a binomial, and I'm looking for a greatest monomial factor that I can factor out. And I notice that both monomials in this binomial have b in it, and I can factor out the b, and that would be simply b times 2x plus 3. I factored out a b. All right, that would be a simple example of looking for the greatest monomial factor, or common terms. Okay? Let's talk about the newest form of factoring, and that would be grouping. Okay? Grouping. So when you group, grouping will get you into a situation like this, which I will cover first. Do you notice how both of these, let me write this out in color, do you notice how both of these expressions, I guess, that are being added together have something in common? I wrote it out in color so you could really highlight it out. They both have x plus 4 in it. Well, what I can do is I can factor out that common binomial. Maybe I shouldn't write it as a term. That common, I'm going to put binomial here, so that's technically what it is, a binomial, that common binomial. Okay, that common binomial, I can factor out x plus 4, and if I factor out the x plus 4, I'll still have 2x plus 3. I factored out an x plus 4 here, which leaves me with 2x, and I factored out an x plus 4 here, which leaves me with 3. Now, if I double distribute, this will work out exactly to what I had in the first place. Maybe I should do that real quick. Let's just double distribute so that we get the same response. 2x squared plus 3x plus 8x plus 12. I'm getting 2x squared plus 11x plus 12. Now, you might be looking and saying, well, Mr. Lemansky, that's not what it is up here. Yes, it is, because let's actually simplify this. I get 2x squared plus 8x when I distribute the 2x through there. And over here, I get 3x plus 12. Well, right there, you can see I have the same thing. All right, so when you factor out the x plus 4, and you get to here, these expressions will give us the same results. I have now factored this. If you go to your book, they're going to have you practicing things that are already grouped to start, and then I'm actually going to go through how we can group it if they're not grouped. Like here in number 3, you can see I have x times x minus 8 plus, I'm going to put a 1 in here, times 1 times x minus 8. I'll just put a little 1 in here because that's what would be there. Do you notice how both of these have an x minus 8 in common? So I'm going to pull out the x minus 8. It won't let me erase that. There we go. It will let me erase it. I'm going to pull out the x minus 8 from each term, and I am left with x minus 8 times x plus 1. I just pulled out an x minus 8, and I'm left with x plus 1. All right? Here would be another example. Problem 8, 7c squared times c plus 9 plus 2 times c plus 9. If I get up my highlighter, do you notice how both of these have a c plus 9? Binomial. I can factor out the c plus 9 binomial, and I'm left with, and you can see it here, I'm left with 7c squared plus 2. Just factored out c plus 9. All right? Now, let's actually go over how we group things so we can apply what we just learned. Now, if you notice here on this 4-term polynomial, there is no common factor. Like, I can't pull an x out of all the terms, and there's no common factors. So the only way I can factor a 4-term polynomial is to try to group it. So here's what it means to group. I'm going to use parentheses. I'm going to make this a group. I'm going to take the first 2 monomials and make it a group, and the last 2, and I'll make it a group. And I'm going to treat these momentarily like separate little problems. So if I go over here, I do see a common factor. I can factor out x squared, and I'm left with x plus 1. You notice if I redistribute, I'd get right back to here. And then over here, I can factor out a 2 from both. So I factored out a 2 from this monomial and a 2 from this monomial. Now, if you look here, and maybe I should use a highlighter or blue, you notice how, let me just underline it. Do you notice now how both of these have x plus 1, the binomial x plus 1 in common? Well, I can factor out the x plus 1, and I'm still left with x squared plus 2, and I just factored number 13 now. Okay? That method right there is called grouping. Here's another problem I can group. I have a 4-term polynomial, and there's no greatest monomial factor that I can pull out of all of them. So I'll group and group. Group the first 2, group the last 2. And now I'll work with the first 2. I see that I have a y squared in common. I'll factor out the y squared. And here I didn't have anything in common to factor out, so I'll just put a 1 in front. I'll just put a 1 out front. And now if I get out my blue pen, do you notice how both of these expressions have a y minus 9 binomial I can factor out? So I'll factor out the y minus 9, and I'm left with y squared plus 1. I just factored number 14. Number 10. If I go back to 10, you notice this is already been grouped a little bit, but I notice here, wait a minute, I don't have a common binomial. I have y minus 4 here, but this is 4 minus y here. These are not in common. I can't just pull them both out. They're not the same thing. So what do? Well, what I can do, first of all, is let's notice here, this is not written in the proper order. Maybe I should have done that in red, actually. Let me erase that. I'm going to do this in red because there's a little, I don't want to know if I want to say a mistake, but y minus 4 is not written properly. I do not have the highest degree term first. So let's fix that. And when I write it here, I fixed it. Okay, well, let's factor out a negative 1 from negative y plus 4. So if I factor out a negative 1, think about it. If I factor out a negative 1, if I pull a negative 1 out of here, this didn't change at all. But over here, negative 1, since I factored out the negative 1, I have negative 1 times 5, which is now negative 5. When I factor out the negative 1, the signs change. Now I want you to notice here, I do have a common binomial now, and I can pull that common binomial out, and I'm left, or factor it out, and I'm left with y minus 4 and y squared minus 5. Okay, so now that we've talked about grouping, let's just go through some examples of factoring completely. That means the whole 4-step list I gave you at the start of the video. All right, so here we have a binomial. And the first thing I'm looking is, do I have any common factors? And I immediately notice, remember, factor completely, factors means keep on factoring until you can't anymore. First thing to check on, do I have a common factor? And I do. I can take an x squared out of both of these. Okay, so I'd say, so this is correct. I have x squared times x squared minus 1. Now, a lot of people, or a lot of students I see would just quit here, but you got to notice here, let me put a little something in here. I notice right now I have a difference of squares, because isn't 1 squared 1? Okay, this is a difference of square. And remember, back in section 9.7, I learned a little shortcut when I have a difference of squares. All I need to do is write this as x plus 1, x minus 1, and I have it. So I still have the x squared out front, but what I'm underlining in blue actually factors into x minus 1, x plus 1, and now I have actually factored this completely. So 23 being factored is x squared times x minus 1 times x plus 1. All right? Here's another one, number 33. They want me to factor this completely, and I see a trinomial. Well, the first thing I got to check on is, do I have a common factor? And I definitely have a common factor. I can definitely divide each of these by 3. And I definitely can pull out at least 2 factors of w from each. This has 4 factors, this has 3, and this has 2. I can pull out or factor out a 3w squared. So when I factor out 3w squared, I'm left with w squared, 8w, and 16. All right? Now I'm looking at this, and I'm like, I see another shortcut. Okay, this is why the shortcuts are good, because if not, you're going to have to think about what times what is 16 and adds up to 8. I immediately am noticing, wait a minute, this is a perfect square trinomial. And the reason I can tell it's a perfect square trinomial, I got to spell that right. So I can tell immediately because I know that 4 squared is 16, w squared is w squared, and if I take w and 4, multiply it and double it, I get 8w. So when I know it's a perfect square trinomial, I immediately know that I'm going to get 3w squared is what I factored out, and I get w plus 4 squared. I get this right away. Now, if you didn't notice the shortcut, you would have had to ask yourself, what times what 16 and adds up to 8? You eventually would have got to 4 times 4 is 16 and 4 plus 4 is 8, and probably got to here, which is the same as that. Okay? Again, the shortcut just saves you the headache of having to think about it. I'm looking at 36. I want to factor this completely, so I'm looking, do I have a common factor? Well, not every monomial has an h in it. And not every monomial has a numerical amount that I can factor out. So I got a 4-term polynomial. So I'm going to, right away, if it's 4-term, I know I got to group it. So let's group it. Now you got to be very careful. I'm going to put a big blue star here. Very careful with this. Okay? When you're grouping, look here carefully. When I put parentheses here, I have to change the sign because here's why. There's a negative 1 out front. If I don't change the sign, think about this. If I do not change the sign, I screw it up because isn't negative 1 times 25h, doesn't that get me back to negative 25h like it was in the beginning? Right? But look at what happens if I don't change the sign. If I just keep this as a negative, and I'll do this, it's wrong if I keep it like that, what happens when I have negative times negative? You get positive. Well, this isn't supposed to be positive, it's supposed to be negative. So I got to remember that, hey, when I have a negative out front, when I put grouping symbols, the signs inside have to be changed. So negative 25h turned into positive, and minus 100 turned into plus 100. Okay, these were both negative to start, now they're both positive, because if I distribute back through, then I'm going to get back to here. Okay, so now since I've grouped it, I can treat each of these binomials separately. I have a common factor here of h squared that I can factor out, and I can definitely divide each of these by 25, factor out a 25, and now you notice that, wait a minute, I got a binomial that is in common. I got h plus 4 and h plus 4, I can factor that out. And when I factor out the h plus 4, I get h plus 4 times h squared minus 25. Now, it's a mistake here, but a lot of people just quit. If you quit, you've missed something. You didn't notice that I have, think about it, I got a difference of squares here. I have h being squared, and I have 5 being squared. That's 25. So if you have a difference of squares, remember, you can break that up into h minus 5, h plus 5. And I want to do that. If you forget about the difference of squares pattern, then you got to go through the process again of saying I got 0 h's, and what times what's negative 25 and adds it to 0 in the middle. Okay? If you notice the pattern and you understand that shortcut, you can avoid thinking about that whole mess in the first place, which will save you time and effort. All right? So I just factored completely, number 36. Let's go to 47. I want to solve this equation. So I got to use what I've just talked about regarding factoring completely. So the first thing is, do I have any common terms in this, common monomial factors in this trinomial? So as I'm looking at this carefully, I notice I can definitely divide each of these by 3, because 3 goes into 3, 3 goes into 24, and 3 goes into 45. And I can also factor out a b. They all have a b in common. So I'm factoring out 3b, which leaves me with b squared, 8b, and 15. All right, now this is not, there's no shortcut to this. This is not a perfect square trinomial. It's not a difference of squares. So now I got to go and think about, since the lead coefficient's 1, what times what's 15 but adds up to 8? And I know 5 times 3 is 15, and 5 plus 3 is 8. So I'm going to factor that into 3b. I have b plus 3, b plus 5. So that's what this will factor into those. Okay? Now remember, we learned this in section 9.4. When you're multiplying and you're getting 0 for a response, one of these have to be 0. So either 3b has to equal 0, or b plus 3 has to be 0, or b plus 5 has to be 0. One of these have to equal 0. Well, 3b equals 0 is easy. B would have to be a 0. 3 plus b equals 0 is pretty easy. B would have to be negative 3. Or b plus 5 equals 0. B would be negative 5. Probably the first time in your life you've gotten 3 solutions for an equation. Now this is something I should talk about real quick that's interesting. Look at the degree of this. It's third degree. Is this a coincidence, do you think? You got 3 responses. When we've worked with second degree equations, you've gotten 2 responses. Think about something really basic like this. Isn't this first degree? You get 1 response. The degree of the equation will typically tell you how many solutions there are. Remember back 7th and 8th grade, you learned here 1 solution. It's first degree. All right? Here's another one just to make sure we're okay with factoring out greatest monomial factors. This is not an equation to solve. They just want us to factor the greatest monomial factors. So as I'm looking at this, I'm thinking, well, I can definitely divide this by 2 and this by 2. Definitely divide both of these by 2. This has 5 factors of x and this has 3. I can definitely factor out 3 factors of x. And this has y and this has y. I can definitely factor out a y. So I can factor out a 2, an x cubed, and a y, which leaves me with an x squared here, and I have 81 here. A lot of people just quit here. If you quit, you did not notice, and you definitely want to notice, I have a difference of squares right here. Think about it. I have x being squared, and I got 9 being squared. 9 squared is 81. Well, the difference of squares, you just take x minus this and x plus that. So there I completely factored it. Okay, I think I've done enough with the video here. I think I'm going to stop right at this point. And if we have other questions that we want to look at, we can talk about those tomorrow. But anyway, that will finish up Chapter 9 and the last way or the last method of factoring, which is factoring by grouping when we have 4 terms in our polynomial.